big as this one, the full screen. Yeah, hope they know how to fix it. All right. 3 topics in this lecture. Insertion sort, a very basic sorting algorithm. Binary search, very fundamental, okay? And a median problem. 3 topics. Okay. All right. First unit, decrease and conquer. You're familiar with, divide and conquer. So why this decrease and conquer? So very similar. So if you look at its meaning, basically it is divide and conquer. Okay? So let's see what's the meaning. So it is a special case of divide and conquer, but look at from the decrease of the size, but divide, that's the way we decrease the problem size, right? Yeah? So your decrease close to divide, right? So, all right. So let's look at the meaning. Yeah, so here you can see exploiting the relationship between solution to a given instance of a problem and a solution to its smaller instance. Okay? That's the typical situation for divide and conquer. Okay? The question is how to divide. Okay? So there are several ways to divide. Okay? The first way, decrease by a constant. Every time we decrease the problem size by some constant. Yeah. Most common situation, we decrease by 1. So decremental. Yeah. That's the, most popular way we solve the problem. Decremental. Yeah. Decrease by a constant factor. Yeah. Constant factor, that's different, right? Constant factor, yeah, divided by a constant. Yeah, constant factor. So that's a, minus constant. So divided by a constant. So constant factor. Now, also possible, divided by 2, for example, right? Every time you split the problem, 2 equal size, divided by 2. Divided by 3, you split the problem into 3 equal size subproblems. Okay? Divided by a constant. Yeah. Another situation. Okay. Variable size decrease. Yeah. Sometimes you decrease more, sometimes, variable size decrease. It's also possible. Yeah. So typically these 3 cases. Yeah. Okay. Yeah. So how different? So in my opinion, the same thing. Yeah. So here I think mainly the author likes to use this decrease and conquer. But so in my opinion, same thing. When we talk divide and conquer, we consider these cases. Right? Yeah. So here the author just emphasized this decrease. That's it. Okay? Emphasize that decrease. Yeah. That's it. But the concept is not new. The whole concept, we cannot say there is a completely new concept created. It's not that case. Okay? Just the terminology change slightly. Yeah. All right. So, all right. Yeah, we can still consider divide and conquer. Okay? So it's not a new type of problem solving technique. Okay. All right. Recursive or non-recursive. No. So, we talked about this before. Okay. Suppose that a relationship has been developed between a solution to the original problem of a subproblem. So we get a recurrence relation. Here, for the implementation, we need to consider which way to do. Yeah. Because when we do divide and conquer, we derive a recurrence relation. Yeah, so we derive that relationship, recurrence relation. Now you need to write the code. You need to write your program. So you have two options, recursive way, non-recursive way. Non-recursive, iterative, we can do it, right? We can solve iterative way, non-recursive. So it's possible. Yeah. Yeah. It results in naturally, yeah. So because the relationship is recurrence relation. So naturally, so people may feel using recursive implementation. Yeah. But you need to know there is some reason to choose non-recursive. Okay. Yeah. Yeah. Iteratively. We know there is advantage of this way. Okay. Stack, here we do not have deep stack. Okay. Main advantage. We have to use stack. No, it's invisible because when you use stack, you do not know it, right? As a programmer, or most of our programmers, you do not know internal implementation using some deep stack. You do not see it. Okay? Yeah. But when you learn this topic, so now you know it. Okay? So you know that a lot of resource used, comparing these two methods. Yeah. But that does not mean we never need to use that, because sometimes you cannot convert it. So given recurrence relation, it is too hard to convert it to iterative implementation. Iterative implementation. Tower of Hanoi. How can you convert it to iterative implementation? You cannot. Nobody can convert Tower of Hanoi to iterative implementation. So that's why sometimes even we know the resource cost very high. We have to pay it. All right. All right, so storage space. Yeah. All right. Then the method to use iterative way, usually we use the method bottom-up approach. What's the bottom-up? We solve the problem from smaller size. Fibonacci number, let's start from Fibonacci number of 2, 3, 4, 5. Okay? Bottom up. Yeah. The last one is n, Fibonacci number of n. Okay? That's the bottom up, not top down. Top down means you start from f of n, but you couldn't solve it. You have to go to f of n minus 1, f of n minus 1. That's top down. Okay? Yeah. Now we do bottom up. Okay? Yeah. So that's another concept. Yeah. Top down, bottom up. And especially when we learn dynamic programming. Yeah. Our last topic of this semester will be dynamic programming. When we use dynamic programming, we have two basic approaches, one bottom up, another top down. Okay. They have advantages and disadvantages. Yeah. Yeah. Sometimes, bottom up, has some advantage. Yeah. Non-recursion, right? Non-recursion, Yeah. Yeah. But top down has its own advantage sometimes. Because when you use bottom up, you need to calculate all the subproblems, right? You need to calculate all the subproblems because you cannot predict what subproblems you do not need to calculate. You can skip. You can bypass. You cannot predict that. So the only way is you calculate all the possible subproblems. But for some of the problem, we do not need to calculate all the subproblems. We only need to calculate some of the subproblems. We can skip many of the subproblems. In that situation, top-down has an advantage. Yeah. That's for the dynamic programming. So yeah, at this point, so we don't need to go that far. Okay? Yeah. So this is just, for our later discussion. All right. Yeah, smallest instance, but you need to consider all the. Okay. So iteratively solve larger instance incremental. Every time you add the size by 1. Okay? Add the size by 1. Okay? Yeah, like that. Okay? Yeah. Yeah. But it's also possible add size by constant, right? Add constant. Yeah. But the last step, you need to get to the right size. Anyway, so here it's an abstract discussion. Abstract, conceptually understanding. Okay. All right. Okay. That's the first unit.